I gave this to you guys before we parted ways last week. What I wanted to do today is talk about this first section and then just make a short video on section 9495 and then make another video for Wednesday on 96 and 97 with some practice, and then make another video for Wednesday that has a little bit of temperature conversion with some practice on it. All right, so there'll be a couple short, they'll look like there's a lot of them, but I'm going to try to make them short. All right, so pause the video, and then I want you to go through all of these, and there's a few on the back, and tell me if these statements are reasonable or not. And I just wanted to see, how much you know about the metric system. So we have the U.S. system, that's yards and feet and inches, and then pounds, and then we have the metric system, that's meters and kilometers and milligrams and grams. So take a minute, see what you can think. Just think outside a little bit of what we're used to, and see what you think is a reasonable statement versus not. And then turn the back on and we'll talk about it. All right, so usually we equate like a meter stick and a yard stick. Like I have a yard stick at home. But I know in the science labs, which I would have brought one into class, I would have brought in a meter stick. So you can see that a meter is just a little bit bigger than a yard. Like a meter stick is just a little bit bigger than a yard. So I'm thinking, when I think of my yardstick, that 20 would be a really big bed. So 20 yardsticks or 20 meter sticks, no, that's like a crazy big bed. Nope. So that would not be reasonable. But a window, like I'm looking at the window in front of me, that's actually probably bigger than a meter by a half a meter. So yeah, that's definitely something that you would see in your house, is a window that measures a meter by a half a meter. So a drinking glass, glass, that would be glass, is made of glass 2 millimeters thick. Now that's pretty reasonable. Most people think like a millimeter is maybe about the width of a credit card. So I have some glasses at home that have a pretty thick lip on it, like even like a mug. So yeah, I would say that that's pretty reasonable. A paper clip is 4 kilometers long. So usually when we think of a kilometer in the U.S. measurement, that's kind of associated with a mile. Now a mile is a little bit bigger than a kilometer, but I'm hoping that you'll agree with me that a paper clip is not going to be a kilometer or like a mile long. Like that's just goofy. All right, goofy. Model's hair is 30 centimeters long. So sometimes the rule of thumb is a centimeter is the width of your pinky nail. So I can imagine putting 30 pinky nails together. That's not that long, unreasonable, and imagine that someone's hair is 30 centimeters long. Yeah, that's pretty reasonable. I'm trying to think of someone in our class whose hair is long, like Hannah. Your hair is probably, Hannah with the long hair, your hair is probably at least 30 centimeters long. So if you're thinking about Hannah, who sits next to Ethan, her hair is definitely 30 centimeters long. So that's something that's pretty reasonable. The distance across the Colorado River. Now the distance across, not the length, but across. 50 miles, or 50 kilometers. That's like from here to Bath. I don't think that that's a reasonable width. A length, yes, but the distance across, like if we were swimming across it, no, that's much too long for a river. Anyway, a doctor prescribed a pill containing 2 kilograms of medication. Now that's a lot of punch in that medication. So 2 kilograms is probably about 4 pounds. So I'm thinking that's pretty crazy. That would have, you would be taking a lot of pills if you were taking 2 kilograms of medication. That's crazy. But a bag of flour weighs 4.5 kilograms. Yeah, that's like a 10-pound bag of flour, which are hard to find these days, by the way. I was trying to find some foolishly, and I could not find any anywhere. I would love to have a 10-pound bag of flour. So, yeah, that's reasonable. A full-grown cat weighs 15 grams. All right, a gram is like the weight of a large paper clip. So I'm thinking 15 paper clips would not be the weight of a full-grown cat. My cat is very fat, so that would be a big no for Leo, our cat. A car weighs 2,000 milligrams. Now we're going to see soon that milligrams, if we convert that to grams, that's going to be about 2 grams. So that's 2 paper clips. So even a little Matchbox car is going to weigh more than that. So that's a big fat no. 72 degrees Fahrenheit room feels comfortable. Yeah, that's probably what our classroom is. Sometimes I think it's a little on the warmer side. So yeah, most people would think that that's pretty comfy. Josiah has a fever if the thermometer shows his temperature to be 40 degrees Fahrenheit. All right, Josiah is not even living right now, people, right? Our normal temperature is around 98, so if he's like close to freezing, he's probably not doing too well. So not only does he not have a fever, but he's close to being frozen. So that would be a big fat no on that one. And then this one, I don't know. Now it 25 degrees Celsius would be lovely right now, but unless you're familiar with Celsius, then you probably aren't clued in too much with this one. So let's hold this one until we talk about temperature and going back and forth between Celsius and Fahrenheit, and then it will be easy to determine that you would not need a winter jacket outside if it's 25 degrees Celsius. That would be goofy. But we'll hold out on that one, okay? Because a lot of us don't have a good sense. I don't have a great sense of Celsius. So we'll have to talk about that when we do temperature conversions, which, see, I have it here. We're going to do temperature conversions and more practice on a Wednesday video, and then Friday is review day. So we'll hit some temperature together at a later time. An air-conditioned room is comfortable, set at 60 degrees Celsius. We'll find out soon that is a crazy talk. So I won't put a no there. We'll come back to it when we start doing some temperature conversion. Claire took a dose of 2 liters of cough medicine. All right, Cheryl. Those big things that Cheryl's drinking, that is a liter of, those 2 liter bottles of soda. So I'm thinking that is not what 2 liters of cough medicine, well, let's just put it this way. If Claire took this, her cough would definitely be cured, right? Because she wouldn't even be alive anymore. So yeah, her cough would be cured, but that not in a good sense. So I'm going to pop a big old no on that one. Jeannie likes to relax in a hot tub filled with 3,000 milliliters of hot water. You know what? I was just drinking. I filled up this vitamin water with just plain water. This is 500 milliliters. This like normal drinking bottle of water. 500 milliliters. So 6 of these. There. That's how big it is compared to the paper. Do you think you'd want to take a bath in 6 of these? No. You barely cover the bottom of the tub. So that would be a no. John drank 250 milliliters of milk for lunch. Yeah, so if this is 500 milliliters, you see it's the width of my paper. So yeah, drinking like half of that of milk would be decent. Yeah, that's reasonable. And then Sarah pumped 20 liters of gasoline in her car yesterday. And we're going to talk about liters and gallons, but 20 liters, think about Cheryl, that 2-liter bottle of soda that she has in class every once in a while. So 10 of those, you could easily fill your car with 10 of those. So yeah, that's pretty reasonable. So it's hard because we're so used to gallons, like we buy milk in gallons. The only thing I can think of is that we do buy sodas in liter bottles. but it's hard for us to think about things. I know what a gallon of milk looks like, but a liter of milk I'd have a little bit more trouble with. So this is kind of a little challenging section to wrap our brain a little bit about what metric measurements are. So let's just do then 2 short sections, and then we'll take a break and we can practice those. And then on Wednesday I'll make 2 more videos for us to practice with, and then we'll be done with what we normally would have test number 4 on. So we'll review on Friday. Right, there won't be a new video. I'm going to send you a review, and then I'll post the key on Monday when you're going to hand in that review. That's going to be your oh wow for the weekend. And then we'll forge ahead. We'll talk about the next week that we have before spring break. All right, so let's just do a review. If we have a 6 on the top and a 6 on the bottom, we know that those reduce down to 1. Same with 19 over 19. If you have the same number on the top as you do on the bottom, it equals a 1. Same with measurements. If 1 foot over 1 foot, the same number on the top as you do on the bottom, it's equal to 1. And then here's the kicker thing. Sometimes it's in disguise. The 1 is in disguise. Do you guys know that 12 inches is equal to 1 foot? So this is really the same as this, right? 1 foot over 12 inches is just equal to 1, right? So this is what is called a unit fraction. It's a fraction that really simplifies down to 1, but it's in disguise. It's not so obvious, like 19 over 19, we know it's just 1. So let's look at some unit fractions. So you can flip it. You could say 12 inches is 1 foot. Did you guys know there's 3 feet in 1 yard? So, put equals 1. We could have 1 yard over 3 feet to equal 1. Or we could put 3 feet on the top and 1 yard on the bottom, and that also equals 1. Right? As long as you have the same amount on the top as you do on the bottom, it's going to equal 1. You don't have to memorize these. These charts are on your final exam, so this is not anything you have to memorize. It would be on your test too. How about 5,280 feet is the same as 1 mile, so that equals 1. Or 1 mile is the same as 5,280 feet, and that also equals 1. All right, so we're going to use these unit fractions to do some conversions, to go back and forth between different measurements. The science department has asked us to teach you this method. You're going to see this method when you take 970 and 980. It's a little bit different than proportions, which is maybe something that you're used to. But I'll show you some problems on Wednesday that you're going to do in Math 970, so you can kind of see the purpose of doing this method, right, rather than using proportions all the time. All right, so let's convert from one unit of measure to another, and we're going to be looking at these in the U.S. measurement. So the steps I've copied out of the book. So you can there's 2 quick steps. It should be pretty easy. The first step is super easy. So let's look at, we'll do this by following the steps. So I want to convert 75 inches to feet. So step number 1 says write the given measure. So we're given 75 inches and put it over 1. That's step number 1. That cannot get any easier. All you do is take your measurement that they gave you and put it over 1. Super easy. Okay. The next step says multiply by a unit fraction whose denominator contains the given unwanted units. We want to get rid of these inches. And his numerator contains the new units. We want to have it in terms of feet. So we're going to multiply this by a fraction. Now there are 12 inches in 1 foot. That's on the chart on the previous page. So I want to use this information to write a unit fraction. I want to get rid of inches and be left with feet. So if I have inches on the top and inches on the bottom, those cancel. And then the units that we want our answer to be in need to be on the top. And now we just have to fill in the numbers. So there are 12 inches in 1 foot. Now look, inches on the top cancel with inches on the bottom. And now you just have two fractions. You've got 75 over 1 times 1 over 12. So you can leave it as an improper fraction. If we want to convert it, if we want to convert that to a mixed number, I don't care. I'll have to let you know what it says on the final. So it'll either be this. I'm pretty sure they want you to leave it as a mixed number. But in either case, this is how many feet are in 75 inches. All right, let's practice. All right, we've got 34 miles. So step number 1, take what you're given and put it over 1. And then we're going to multiply by a fraction. All right, that's step number 1 and part of step 2. Now we want to get rid of miles and be left with feet. So the unit you want to get rid of, for your unit fraction, you're going to put that unit on the bottom, and the unit that you want to be left with has to go on the top. So now I can cancel the miles. And then you've got to fill in the numbers. So if you look on the previous page, there are 5,280 feet in 1 mile. So miles cancel. And then you pull out your calculator. Now do you see the denominators are all 1? So you can just say 34 times 5,280. Right? 34 over 1 is 1. 5,280 over 1 is 34 over 1 is 34. 5,280 over 1 is just 5,280. So you really don't need to use the fraction key if you don't want to. There we go. Think about it. There's going to be a lot of feet in 34 miles. So 179,520 feet. All right, let's try. We're going to come back and do this two-step one at the end. Okay. That's not a two-stepper. Wait. Yards to feet. We have yards to feet, so that's not a two-step problem. So, I think I meant like these ones down here. So let's cross this off. Boop, 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 boop. And then these ones are the two-steppers that we've got to worry about. Okay, so ignore that line. So we've got 6.5 yards over 1. Isn't that the first step? And then we're going to multiply by a fraction. Okay, so now I want you to try it. Where are you going to put yards so you can cancel the yards? And where are you going to put feet so you're left with feet? So where are we going to put the yards so we can cancel the yards on the top of that first fraction? So if you have the same thing on the top as you do on the bottom, you can cancel those units, and then what you want to be left with goes on the top. And then you got to fill in your numbers. So there are 3 feet in 1 yard. If you, well, let's cancel the yards. If you want to just put it in as 2 fractions, it'll work. Right? That'll work. You can leave it as a decimal. We'll just leave it as 19.5. And that's feet. All right, miles to yards. So let's flip back. Do we have a miles to yards? We do not. Now look, we have miles to feet, and then feet to yards. So this is what I call a two-stepper. Okay? You're going to need 2 fractions. This is a hard one. So we're going to do this one together. You ready? This is a tough one. I'm not going to lie. You'll have a bonus. This is a bonus on the test, okay? So this one's a bonus. So we've got 1.4 miles. And we're going to put it over 1. Now, I'll let you know it's a two-stepper, so I'm going to put 2 fractions in there. So I can go from miles to feet. That's the only conversion I was given. Look, miles to feet. I don't know anything else but that. So I can get rid of miles and be left with feet. But remember, I want my final answer to be yards. So now the miles cancel, and then now I'm left with feet, but I want to be left with yards. So let's get rid of the feet and be left with yards. So now the feet cancel. And now let's fill in the numbers. You ready? So in 1 mile, there's 5,280 feet. And then how many feet are in a yard? You don't need to memorize this, but because the chart will be given to you. But there's 3 feet in 1 yard. So do you see the miles cancel, the feet cancel, and I'm left with yards. So now I've got 3 fractions I'm going to multiply. So 1.4 over 1 times 5280 over 1 times 1 over 3. There you go. 2,464 yards in 1.4 miles. Okay, so cover that up. And see, this is a different one from miles to yards, but it's 5 miles to yards. So cover that up, or use that, if you need to use it, and see if you can pause the video and do this one, and then try this one. This is just a one-step problem, because you're given inches to yards right there. Okay, so this is a one-stepper. So pause the video, right, and then see how you do on those two. All right, here we go. So we've got 5 miles over 1. That's what we're starting with. Okay, and then we're going to multiply. This is a two-stepper. And I'll let you know if it's a two-stepper. I'll tell you it's a two-stepper, so you're going to have to make 2 arrows, or 2 fractions. All right, so I want to get rid of miles. So the only thing that the chart is going to give you is miles to feet, so it's not a big stretch to figure that one out. And then I can go from feet to yards. Okay, so then you just have to fill in the numbers, right? The miles cancel, the feet cancel, and I'd be left with yards. Okay, so in 1 mile, there's 5,280 feet. And then in 3 feet, there's 1 yard. So now I've got 3 fractions. Put those in my calculator. I'm going to get 8,800 yards. All right, if you didn't try this one, pause the video and try it, okay? All right, so I'm hoping you went 180 inches over 1. And it's not a two-stepper, so I just need 1 fraction. I want to get rid of inches, so I'm going to put inches on the bottom, and what you want to be left with goes on the top, and I want to just be left with yards. So flip back, because now we got to fill in the numbers. Right, do you see it right here? In 36 inches, there's 1 yard. Do you see that? So there are 36 inches in 1 yard. Inches cancel. And then take your time, pull out your calculator, and I just enter in the 2 fractions. So I have 180 over 1. And I'm going to multiply that by 1 over 36. So it looks like we've got 5 yards. Okay? So you know what? I think I'm going to stop the video now, and then I'll make another video for the next section. So we just kind of hit in one section at a time so they're not too long. Okay? So maybe you even want to try the My Math Lab for this section. I'm going to stop it now though, and then if you're looking at the My Math Lab, we just did section 9.4. That's U.S. System